For centuries, we looked up at the night sky and assumed our home was entirely unique. But as our technology evolved, we realized we share this galaxy with thousands of alien worlds, each with its own specific rules of physics. Deep within the data processed by these mission control centers, astronomers isolated a signal from a planet located 64 light-years from Earth. To our instruments, HD 189733b registers as a deep ocean blue sphere. Set against the harsh radiation of its host star, it mimics the visual profile of our own planet. Light can be deceptive. This specific shade of blue reflects a chemistry far removed from the water-rich atmosphere of Earth. Instead of calm seas, we are observing an environment defined by physics that would be physically impossible on any planet in our own solar system. The mechanism creating that inviting color is the same force that drives the planet's lethal environment. The atmosphere of HD 189733b contains no water vapor. Instead, it is saturated with clouds of silicate particles, microscopic grains of sand suspended in the air. This diagram shows how the optical trick works. As intense starlight hits the atmosphere, these jagged silicate particles absorb the red and yellow wavelengths. They scatter blue light back out into space, projecting the image of an ocean. The planet's climate is driven by its proximity to its host star. It sits so close that the gravitational pull has forced it into a permanent state of tidal locking. The orbital model reveals the planet does not spin independently. One hemisphere is anchored facing the star, leaving the dark side in permanent shadow. The day side absorbs relentless radiation, pushing temperatures past 1,000 degrees Celsius, while the opposite side faces a deep freeze. Physics dictates that such a massive temperature gap creates violent movement, as cold air rushes to replace rising hot air. Here, that thermal disparity acts as a permanent atmospheric engine. The thermal vacuum forces planetary winds to accelerate to speeds exceeding 5,400 miles per hour. This is more than 7 times the speed of sound. These winds outpace modern fighter jets, circulating the entire planet in hours. On the day side, the 1,000-degree heat is so intense that the suspended sand particles melt, forming droplets of liquid glass in midair. Those droplets are caught in the supersonic air currents, creating a continuous storm of high-velocity projectiles. Because the wind currents are moving horizontally at Mach 7, the glass doesn't fall toward the surface. The pressure forces it to rain completely sideways. A human entering this atmosphere would be instantly shredded by billions of glass fragments, traveling faster than bullets. Given that nothing can survive here, agencies like the European Space Agency and NASA dedicate massive resources to studying it for a specific reason. Identifying the chemical makeup of an exoplanet requires capturing trace amounts of infrared light filtering through alien atmospheres trillions of miles away. These engineering projects are our only tools for penetrating visual deceptions in deep space. Without them, HD 189733b would remain a harmless blue dot in our data. Studying a world this hostile serves as a stress test for our planetary models. By observing weather systems at these physical limits, scientists calibrate the parameters used to identify genuinely habitable worlds elsewhere. These extreme findings remind us that the physical universe is largely indifferent to the delicate conditions required for life. HD 189733b demonstrates that a planet can mimic Earth's appearance while harboring conditions that defy our expectations of planetary evolution. It suggests the census of the galaxy contains worlds that fall far outside our current definition of a stable environment.